The Model Context Protocol MCP is a great invention and very successful in practice, although it comes with some issues. One of them is context overload. In this video, I want to discuss this issue and, of course, some potential solutions, which is interesting for AI tool users and tool builders. I'm Jonas from Eclipse Source. Let's dive into it. So what is the problem of context overload and how is it related to MCP? Let's first discuss about tools and context overload, because as you might know, MCP is mainly about providing the right tools for AI agents. Now, why are tools potentially problematic? Let's use a metaphor. Let's assume our AI agent is a handyman and the task is to assemble a wardrobe. So the ideal situation would be like this. The handyman has the instructions, mainly what, for example, we provide to the agent, and all the tools to do its work, and they're nicely assembled. So very easy, very good context. However, in practice, many AI agents are rather in this situation. So they have many, many tools available, and it's really, really distracting. And this, in practice, really lowers the efficiency of agents. Now, before we discuss how MCP plays a role in this, let's discuss why this is actually a problem for AI, because you might assume AI is so clever it can just deal with a lot of tools. In our handyman metaphor, what any handyman would do if they're in this situation is to remove all the tools that they don't need first to get back to this situation. LLMs are not capable of doing that. As they are stateless, they need to get all the available tools with every request, and they have to pick and choose between all the available tools then. Even worse, a handyman typically knows all the available tools by heart. They have learned how to use them, they have experience. For LLMs, the situation is again different, as most of these tools are typically designed by tool providers or tool builders. LLMs have no previous knowledge about them. So, along with the tool, they also get a full description of the tool, which makes the problem even worse because it adds a lot of context to the request. And if you need numbers, as we have shown in a recent video, with a coding agent, a set of standard MCP servers, like, for example, Playwright, GitHub, and maybe an IDE MCP server, can easily already eat up 20% of the context window of Opus 4.7. And as a rule of thumb, you should actually stay ideally below 40%, including all the context you add with the task, all the files it reads in. And if you consume already 20% only with tools, that is really a problem. It will distract the underlying LLM and the agent and lower the efficiency. Now, how is MCP connected to all of this? The irony in the story is that the two issues that MCP contributes to this context overload problems are also the two greatest things about MCP. Number one is MCP servers are typically not provided by the same party that writes an agent. And that is a huge success of MCP because, for example, many third-party system providers provide MCP servers for their system. As an example, GitHub provides an MCP server that allows all the agents out there to access GitHub. And that's really great because it lowers the effort to connect to GitHub. However, because this GitHub agent is not designed by an agent designer, but by GitHub, they, of course, do a generic set of functions. They try to provide as many features as possible, as many functions as possible, and they are very generic. Now, the problem is we have a lot of functions, and if we integrate all of them in our agent, the agent might not even need them, and we provide too many tools. And as we have just shown, that's problematic. The second issue, and that's also something that is super great about MCP, is that it is so easy to integrate MCP into agents. In many tools, especially in IDEs, the end user can even do that. And it's very tempting to activate a lot of MCP servers. And many tools do not provide a fine-grained control which of the tools provided by one MCP service you actually want. So what many users do is they activate a lot of MCP servers, including all their tools, again, contributing to this problem. Now, I'm not saying that the general model of MCP is wrong or bad. It's super great and successful, but these two factors contribute to the problem of too many tools. Now, how can we potentially solve this? The first very obvious and global solution would be to follow the handyman example and enable LLMs or agents to discover tools and only load them on demand. And there are many approaches suggested in this direction. in November 2025, Anthropic proposed or released in public beta their tool search or deferred loading approach. So I think we're getting in this direction globally. I was personally a little bit surprised that the new skill model, also proposed by Anthropic, doesn't include this. It would be nice if skills would also contain MCP tools, or could contain MCP tools. So when a skill is loaded, the LLM also get access to a predefined set of tools. So we're getting there, but what can you do today in practice if you don't have this approach yet? Solution number one is control the tools that your agent has access to. Don't provide your agents with full MCP service if not needed. If you design agents yourself, really select only the tools that you want. If you use tools that can access MCP servers, have a look what you really need. Tools like VS Code or Thea IDE allow you on a very fine-grained level to only select the tools provided by an MCP service that you really want. Cloud Code, for example, doesn't allow that, so you can only activate and deactivate full MCP service. However, literally yesterday, they introduced this new tool search discover feature into Cloud Code. So they try to solve this problem automatically for you. Number two, potentially use subagents. Subagents are in many systems a way to encapsulate context for a specific subtask of a whole workflow. And in some systems, like for example in Thea AI, they can have their own toolset available. That means you can create specialized agents. For example, one agent that is capable of communicating with GitHub, another agent that is capable of testing applications with Playwright. And of course, you can use this in any domain of your choice. This has the advantage that the main agent doesn't have to have access to these specialized tools, but can delegate a certain task in a whole workflow to a subagent, and only this subagent has access to the tools that it needs to complete this step. Be aware, though, that not all systems that support subagents create a dedicated context for this subagent. So, for example, to my knowledge, Cloud Code that supports subagents still provides the same set of tools to all subagents. So in this case, this pattern wouldn't help. And solution number three is consider the context overload when designing your functions. There are different ways to design functions. You can go very broad with a lot of functions for doing something, but you can also provide only a few very powerful functions. And of course, often simpler functions are easier to use, but there's one particular pattern that works well in practice, and that is if you are able to design powerful functions that are kind of naturally well understandable by the LLM. The Probably the best example for this is the terminal function, for example, used in Cloud Code. So the agent has access to the terminal. And why is this so great? Every LLM in the world understands how to use a terminal. It's in the training data. So you don't have to describe a lot on how to use this function. You just let the LLM use it, basically. And it is very powerful. It can search things, it can grab things, it can rename files, basically anything that it can do on the terminal, only with one function. Just to give you another example, because terminal might be a security risk, in the Thea IDE, the agent is capable of executing all the tasks that the user has defined for a project. And there are only two functions necessary. Number one is to search the right task to be executed. So for example, if the agent wants to execute test, it can search for tasks related to test. And then a second function to execute this. So in this function design, we kind of have this discover pattern or deferred loading pattern already built into the function design. Now, if you're just a user of MCP, you cannot do much about function design, but if you write MCP service or if you write your own agents, you can definitely use this pattern to avoid context overload by the functions that you create. With that, let's wrap up. In this video, we have discussed the issue of context overload and how it relates to tools and MCP. And we discussed some potential solutions for it. I would like to emphasize again that MCP is of course not that, and as you can tell, I'm a huge fan of the concept, but of course there are also issues that we need to solve. Finally, I would like to mention, if you are building your own agentic system or an AI native tool and you need help with the design or the implementation, Eclipsos is here to help. We are your tech partner in designing and implementing tools of any kind in any domain, may it be coding or any engineering domain. And finally, if you like this video, please consider to subscribe to our channel and leave a like, and thank you for watching.